Hello, pre-algebra students. Mr. Lawrence here with your flipped lesson, and we're going to quickly recap the two types of patterns we've learned, and then we've got a new type of pattern to learn today. Hope you're doing your best. Hope you're starting to feel pretty smart about these things because they're really not that difficult, and I don't know about you, but they sure have the power to make me feel like, wow, I can really do this. Okay, first of all, I'm going to make a table around the series 8, 12, 16, 20, 24. Some of you already know what's going to happen because you've been seeing it so much, but I'm going to put 1, 2, 3, 4, 5, and n in here. Then I'm going to go looking for my first differences, and it looks like it's plus 4, plus 4, plus 4 every single time, which means that I'm going to have something like 4n. I make my comparison line, which I think is the easiest thing to do. It just makes it so simple to know what to do to the 4n. That's why I like to do it. So I'm going to put 1 in for n, and I'm going to get 4, and then 8, and then 12, and then 16, and then 20. And then I'm going to compare up, and I like to do that with Poiple. All right, I'm going to compare up. So there's plus 4, plus 4, and then plus 4, and then plus 4, and then plus 4 again. So that means for the nth term, I'm going to do 4n plus 4. And it's just a coincidence that they're both plus 4. That's why I do the one in red. The red one is here. Or the orange one, the red one goes here, 4n. And then the purple one goes in the other place. Okay, so that's the linear pattern, right? I don't know if I've been using that word enough, but I need to start. This is called a linear pattern. And what makes it linear is that the 4n plus 9, it's like there's a little exponent of 1 right here. Okay, that's what makes it linear, if there's an exponent of 1 or you don't see an exponent. All right, so let's look at the second example here. And put my ready-made table there. And we're going to fill in the numbers 1, 2, 3, 4, 5, and then of course n. And then we're going to find our first differences. And it looks like it's plus 3, plus 5, plus 7, plus 9. Didn't find anything, so I go down to the second level. There was the first level. Now I go down to the second level. And sure enough, on the second level this time, I get plus 2 every time. Okay, that means it's going to be something like n squared. So I make my comparison table, and I put 1 in for n, and I get 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Oops, wrong button. There we go. I get my Poiple, and I say, how do I turn 1 into negative 1? Well, it looks like I subtract 2. 4 to 2, I'm going to subtract 2. Alexis can tell us that if I do 9 minus 2, I get 7, and I'm sure Mr. Alexa can tell us to subtract 2 here. And there we're going to subtract 2. So Mr. Strauss, I'm sure you know the answer then, because this is easy stuff. We should be doing n squared, and then I'll do it in Poiple, minus 2. And there you go. And this n squared minus 2, this is a quadratic pattern. Quadratic. And what makes it quadratic is this exponent of 2. If there's an exponent of 2, it's quadratic, meaning if that's the highest exponent. All right, now we're going to look at a new type of pattern. If I can get my pen to work. Okay, so I'm going to bring my handy dandy table over here. And one more time, I'm going to fill in, 1, 2, 3, 4, 5, and n. Now, some of you like to take shortcuts and not do that step. Well, that's fine if you can get the right answer, but if you keep taking the shortcuts and keep getting confused or not sure what's going on after a certain point, then ask yourself, why aren't you doing it the way I do it? I mean, if you can do it your own way and get the right answer, I think that's pretty smart. But if your way isn't getting you the right answer, then you need to check it out. Check out what I'm doing. Try it. Okay, here we go, plus 2. Here we go, plus 4. Here we go, plus 8. Here we go, plus 16. Uh-oh, I don't like this. If I go down to the second level, I'm going to get plus 2, plus 4, plus 8. Do you notice the differences are repeating? I got a 2, 4, and 8, and then I get a 2, 4, 8. If I had the next number in this sequence of 64 and I did it, I'd get a 16 here. All right? This thing is going to go on forever and ever and ever if I have enough black numbers going across. So this isn't a good way to do this one. After I got the first difference, sorry about that, I happen to notice, though, that something was going on here. Look at this. Isn't this times 2 times 2, right? 8 to 16 times 2. If you ever notice the numbers doubling or the, the differences being doubled, then your nth term is going to be something like the 2, but it's going to be to the power of n. And I can show you why. Let me move this stuff out of my way. Do you know another way to write the number 4? You should. I'll bet you Austin could tell us that it's 4 is the same as 2 times 2, or better yet, it's 2 to the second power. 8 could be 2 times 2 times 2, or 2 to the third power. 16 could be 2 to the fourth power. That would make 2 2 to the first power. And then 32 would be 2 to the fifth. So let's think about this. For the first one, I do 2 to the first. For the second one, I do 2 to the second. For the third one, I do 2 to the third. Fourth one, 2 to the fourth. Fifth term, I did 2 to the fifth. What do you think I'm going to do on the 81st term? Well, I would do 2 to the 81st, right? What am I going to do on the 125th term? Well, I'm going to do 2 to the 125th power, which is an extremely huge number, by the way. So what am I going to do on the nth term? Well, I'm going to do 2 to the n. Yeah, it's pretty simple. Now I'm going to make my comparison line. And in this case, I'm going to put 1 in for n, and I'm going to get 2 to the first. Then I'm going to put 2 in, I'm going to get 2 to the second, and then 2 to the third, and then 2 to the fourth, and then 2 to the fifth. Well, now I compare up, and in this case, they match perfectly, right? It's kind of like plus 0. So I'm going to write my answer of 2 to the power n. Remember, that happens whenever our differences are doubling. Well, let's take a look at this one. Okay, go looking for my first differences, and I'm going to get plus 2, plus 4, plus 8, plus 16. Hey, look at that. They're doubling, aren't they? Every single time. Times 2, that's times 2, and that's times 2, right? Okay, so that means my answer has to be something like that 2 that was doubling to the power of n. Now I'm going to make my comparison line. I put 1, 2, 3, 4, 5 in for n. To the first, to the second, to the third, to the fourth, to the fifth. And then I compare. Oh, that's plus 3. Oh, there's plus 3 again. There's plus 3 again. And there's plus 3. And there's plus 3. All right. Um, so 2 to the power n plus 3. 2 to the power n plus 3. This is actually pretty simple. The only trick is recognizing that the things are doubling. Okay, one more example, and then this video will be done. All right, I'm going to 1, 2, 3, 4, 5, and n. I'm going to go looking for my first differences. That looks like it's plus 2, plus 4 again, plus 8, plus 16. What do you know? They're doubling, aren't they? Times 2 times 2 times 2. So that means my answer will be something like 2 to the power n. Make a comparison line here. To the first, to the second, to the third, to the fourth, and to the fifth. And then, how do I turn 32 to 29? I subtract 3. 16 to 13, subtract 3. 8 to 5, subtract 3. So my answer is 2 to the power n minus 3. By the way, these are called exponential functions. You want to get good at them because there's a really cool lesson I want to do later on called the Tower of Hanoi, which I think you'll really enjoy. Kids love it every year. But you need to make sure that you understand the exponential. Okay? Remember, if you need some help, come see me. All right, Mr. Lawrence signing off. Good night, everybody.